You know, oh, good morning, everybody. It's St. Patty's Day, and I'm Mr. Ainsworth, and you guys are? Period 4 from?
Professor. Calculus.
Calculus at?
GOHS.
GOHS, Great Oak High School here in Temecula, California. That was Brandon right there. Okay. What we want to do is we learned how to integrate or take the antiderivative of all our trig functions and then kind of mix it up a little bit and integrate that with our polynomials and everything. So specifically, we want to be able to solve integrals involving trig functions with no u substitution. That's going to be lesson 4B, the next lesson. So we're going to start simple here and just go over how to find the integral or the antiderivative of all your trig functions. Now, since the integral is the inverse function of the derivative, we need to make sure you know your derivatives really well. And then if we know those, then you can find the integrals pretty easily. And let's go over one at a time. Okay, so the first one here. Okay, and again, I want to review the derivatives first. And for every derivative, there's a companion rule for the integral. Okay, so first of all, what's the derivative of sin x? Okay, we know that already. Okay, so because of that, if I integrate, let's go over here, if I integrate cosine x dx, you should be thinking of a function. Okay, the integral of cosine x is a function whose derivative is cosine. And what's that function? Sine. Okay, sine x plus what? Be bold.
C.
C. What's C called?
Constant of integration.
Constant of integration there. Okay, you have to have the C there. So for all these integrals, we want to be thinking derivatives. Okay, so if we know our derivatives, this should be doable. Okay, now what's the derivative of cosine?
Negative sign.
Negative sign. Again, let's go slow together because I know you guys have to write down everything here. Any function that starts with a C, when you differentiate it, ends up negative. You guys remember that? Okay. And so since the derivative of cosine is negative sine x, if I want to integrate or take the antiderivative of sine x dx, we're looking for a function whose derivative is sine. I'm positive sine, not negative sine. So what function would that be?
Negative cosine.
Yeah, it has to be negative, not positive, because how do we check our integration? So if we differentiate the result, if you just put cosine here and differentiate it, what would you get?
Negative sign.
Negative sign, and we don't want that. We want positive sign, so you have to adjust it, and you have to say it's negative. Give me a thumbs up if you're with me so far on that. Okay. So if you're really good on your derivatives, you should be able to do this. Okay, so make sure, if you're weak on any of these derivatives on the left, go home, make some note cards on them, practice them like crazy, get really good. Okay, let's help me out again. What's the derivative of tangent? Say it again? No, son. Okay. Secant squared x. It's okay. That's why we're reviewing. Okay? Secant squared x. Go ahead and mark that one. Okay, now, if I ask you to integrate or find the antiderivative, remember those are synonyms. I could say either one, so just get used to both of those, of secant squared x dx. You're looking for a function whose derivative is secant squared x, and what is that function? Tangent x plus what? C. Make sure you put that C down there because the constant of integration can be found if we had an initial condition or solving a differential equation or something. Okay? All right. Now, son, this is the one that you were thinking of right here. The derivative of secant x is what? Secant x tangent x. So secant x times tangent x. So if we find the antiderivative or the integral of secant x times tangent x dx, we're looking for a function whose derivative is secant x tangent x, and that happens to be what? Secant x plus c. So like I said, and keep repeating that, if you know your derivatives really well, the integration isn't too bad because it's just the inverse operation. Okay, now be careful on E here. It starts with a C. What's the derivative of cosecant x? Negative cosecant x times cotangent x. Negative though. And so Okay, so if I ask you to find the integral or the antiderivative of cosecant x, cotangent x dx, you're looking for a function whose derivative is that function right there. What would that be?
Negative cosecant.
Very good. Negative. You said negative. I heard that. So negative cosecant x plus some constant of integration. And last one here. What's the derivative of cotangent? It starts with a C?
Negative cosecant squared.
Negative cosecant squared x. Okay? Negative cosecant squared x. And so, if we integrate cosecant squared x dx, what should we get?
Negative cotangent.
Negative, right? Can't be just cotangent because then we'll end up with a negative function, and so we have to adjust it. So negative cotangent x plus c. Okay, these all, must be memorized, and you will do by doing a ton of problems. Okay? So no cards, anything it takes. Get them down. And then just practice like a madman. Okay? So here we go. Let's put it all together. Let's take what you know and what you just learned right now and put it together and solve all kinds of integrals here. Okay, first one is the integral of t squared plus sine t dt. The integral of a sum is the sum of the integrals. So when you handle something like this, you have to integrate them individually. So the integral of t squared dt plus the integral of sine of t dt. Don't be lazy and leave out the dt's, okay? That actually has some importance and some significance later on in mathematics, so make sure you do that. The first one is going back to the power rule for integration. We add 1 to the exponent, divide by that value, right? So what's the integral of t squared?
T cubed over
3. T cubed divided by? 3. Okay, so t cubed divided by 3. Now that produces a constant of integration, both do, right? But a constant plus a constant just gives you a... So we're just going to write down one constant on the far right after we're done, okay? Now, the integral of sine of t is a function whose derivative is sine. Okay. The integral of sine t is a function whose derivative is sine of t. And that has to be what? Negative cosine of t. Not positive cosine, because the derivative of cosine is a negative sign. So you have to go minus sign here. Cosine of t plus some constant of integration. Okay. Next one, the integral of theta cubed plus secant squared theta d theta. Again, the integral of a sum is a sum and integral. So you want to integrate each one separately. So the integral of theta cubed d theta plus the integral of secant squared theta d theta. Okay, power rule first. The integral of theta cubed would be? Okay, theta to the 4th divided by 4. Okay, now the integral of secant squared is a function whose derivative is secant squared. And what function would that be? Tangent theta. In here. Oh, did I tell you that story yet?
Yeah.
The Masachi?
Yeah. That was a long time ago.
Oh, man.
What I forgot.
Okay, is that correct right up there?
No, plus C.
Thank you. All right, plus C. Okay. Moving right along. The integral of a difference is the difference of the integral. So you want to integrate each one separately. So the integral of 4x dx minus the integral of cosecant x times cotangent x dx. So we need to integrate 4x first. So we're looking for a function whose derivative is 4x. Britt, what would that be?
2x squared.
Who would agree with him? He said 2x squared. Right, because the derivative of 2x squared is equal to 4x. So this is 2x squared. You could have written down 4x squared divided by 2, right? When you use the power rule, but that simplifies to 2x squared there. Okay, now on the next one, we're going to integrate cosecant x, cotangent x. We're looking for a function whose derivative is sitting right there. What function has the derivative of cosecant x, cotangent x? Negative or positive cosecant x? Okay.
No, the sign becomes positive.
Yeah. Well, if you ignore the minus sign up there, you could put down just negative cosecant x here, right? So minus a negative cosecant x. But who sees the double negative right there? So it's going to be actually a sum in a minute. So let's keep the minus sign there and write down negative cosecant x here plus c just to step it out. And then, when you subtract the negative like you guys just said, you add, of course. And so you have 2x squared plus cosecant x. Many of you might have just put down plus automatically and did that step in your head. Am I right? Yeah, I see the head nod. So whenever you want to kick in the those mental steps, that's fine. Okay? Any questions up to this point? Okay. Too bad you guys can't see me on video. I would just say there was something funny out there. Okay, next one. Next example 4. Stepping it up a little bit. Ooh. Check this one out. If we integrate them individually, and we take a look at the integral of cosine or cotangent squared x dx plus the integral of 1 dx, would this be a good way to do it? No. Ooh, Shanika's moving her head saying, no way, no how, Mr. Ainsworth. Why is that? Why is this a bad idea? Yeah, I mean, do you know of a function who has a derivative of cotangent squared x? Does anybody in this classroom know of a function whose derivative is cotangent squared x? No. Yeah, my whole class is shaking their head sideways. They're saying, no way, no how. Okay, no good. Okay, so that's a bad approach. And this is what's going to happen on your homework. You're going to try something, and you're going to get stuck. And when you get stuck, you try something else, right? So what you do is you look over here and you say, hey, you know what? I was in pre-calculus before. That was last semester. I know the identity for that. Tell the person next to you what the identity is. What is cotangent squared x plus 1 equal to? Raise your hand if you don't know. Be honest with me. Okay, thanks for telling me. My class needs a little recall. Okay, so you're going to love this. Here we go. We know.
You know.
Or you know. You know, we know, we all know. Okay. Cosine squared x plus sine squared x is equal to what? That's a 2 right there. Equal to 1. This is your Pythagorean identity. Okay? Now, what would you do to that equation to generate cotangent squared x plus 1? Okay, so let's do it. If we divide everything by sine squared x, just doing something we did a long time ago, we get cotangent squared x plus 1 equals what? What's 1 over sine squared x? Very good. And that's the identity you need. This gets substituted in here. In here. So, what do we have in here? We have this integral. We're going to substitute in cosecant squared x and integrate that, because now we know. We know of a function whose derivative is cosecant squared x. Tell your person next to you, what's the derivative of what function gives you cosecant squared x? Negative or positive? Negative what? Yeah. Negative cotangent x plus c. Okay? So, if you understand that example, you should be able to do example 5. I'm going to pause the video. Okay? Go ahead and start working on both. All right, so we're not going to take the integral of the individual terms. We're going to make a unique substitution. Okay, we know that tangent squared x plus 1 is equal to what? Okay, secant squared x from the Pythagorean identity. So we're going to integrate secant squared x dx instead. So you need to be looking for a function whose derivative is secant squared x, and what is it?
Tangent x.
Just tangent x? Tangent x plus what?
C.
Plus c.
Yeah. Okay, so tangent x plus c. And there you go. So you're going to have fun with your homework tonight. It's on the... Excuse me?